Welcome to our channel. The National Aeronautics and Space Administration, NASA, is one of the most well-known organizations in the world, having been responsible for many of America's greatest achievements, such as landing on the moon. Despite being the most influential organization in the world, NASA can't explain what's happening on Neptune. Number 8. NASA's expeditions to Neptune. It's no surprise that NASA has one of the biggest budgets in history. It's no wonder that they're reaching deeper and further into space. Their most recent expedition is no exception. NASA just announced that they're preparing to visit one of the most intriguing planets. Neptune is one of our solar system's most intriguing planets, and has struck a chord with NASA because of its strange behavior. Now, what is this strange behavior that NASA has discovered on Neptune that has made it their next target? Number 7. The discovery at Neptune. Voyager 2 discovered 6 new moons, took the first images of the planet's rings, and noted a particularly violent storm when it arrived at Neptune in 1989, just 12 years after embarking on its historic journey through the solar system. The storm came as a complete surprise. There was a whirling, counterclockwise wind of up to 1,500 miles per hour, 2,414 kilometers per hour, in the southern hemisphere, the strongest ever recorded. While the Great Dark Spot had vanished by the time the Hubble Space Telescope gazed at the planet 5 years later, astronomers were curious as to why the winds were so strong. Number 6. The issue of the extra heat. They were also baffled by another issue. Despite being further from the Sun, Voyager 2 found that Neptune is warmer than Uranus. The source of this extra heat remains a mystery. Scientist Brian Cox said in his BBC documentary, The Planets. But does this suggest we're dealing with a two puzzle? And may one enigma assist to explain the other? Before we can solve the two difficulties at hand, we must first define what warmer means. We can't measure the global average temperature at ground level on Neptune, since it's a gas giant, whereas we can on Earth's solid surface. Instead, due to the tiny size of Neptune's core, temperature measurements must be performed at a high altitude. Number 5. What did the experts from NASA have to say? We can only measure temperatures in the outermost layers. Planetary scientist Michael Wong of the University of California, Berkeley said in an email. In doing so, we discovered that Neptune isn't truly hotter than Uranus in terms of temperature. They're almost identical. This shouldn't be the case, since Neptune gets less solar light due to its distance from the Sun. Neptune is warmer in terms of how much heat it generates in relation to how much heat it receives from the Sun, based on this closeness in temperature. Voyager's measurements show Neptune emits more than twice as much heat as it absorbs from the Sun, while Uranus does not. NASA's Goddard Institute for Space Studies, Anthony Del Genio, told all about space. And it's at this point that things start to become interesting. That's because Neptune isn't out of the ordinary in this situation. Jupiter and Saturn also emit almost twice as much heat as they absorb, but Uranus does not. Del Genio said, Uranus is an oddball. Number 4. The electricity of Uranus. The progression of temperature as you go further away from the Sun shows Jupiter to be the warmest of the gas giants, Saturn next, then Neptune. Uranus is the one that is out of place, Del Genio said. Yet that unusual result is associated with the fact that Uranus does not have a significant internal heat source. Neptune is able to get up to the same temperature as Uranus, despite the latter's inability to create any heat other than that derived from the Sun. But what is an internal heat source exactly? Simply said, it's heat left over from the formation of the solar system when these planets were formed. The Kelvin-Helmholtz contradiction occurs as the heat in the early solar nebula contracts. The extra heat source on Neptune and Jupiter and Saturn is largely due to gravitational contraction, said Joshua Tollefson, also of the University of California, Berkeley. As the planet slowly gravitationally contracts, the material falling inward changes its potential energy into thermal energy, which is then released upwards out of the planet. Number 3. One mystery leads to another. However, there's no apparent explanation why Uranus doesn't have much, if any, internal heat source. Something must have stunted this process on Uranus, perhaps due to a collision in its early history that knocked the planet on its side, Tollefson said. The question becomes, why does Neptune have an internal heat source but Uranus does not? It's possible that heat isn't emitted from the inside at a constant pace, but rather in burps. We may just be seeing Uranus in a quiescent period, whereas Neptune has burped more recently, Tollefson said. The burps are convection. which may happen in discrete episodes, separated by long time periods, but we may not know if it works this way for sure unless we see one of these convective episodes take place. It might also be due to the fact that Uranus is an elderly dog and Neptune is a puppy. How much heat a planet radiates depends mostly on how old it is and how quickly or slowly it releases that heat. Amy Simon, a NASA senior scientist for planetary atmosphere research at NASA's Goddard Space Flight Center, said, "An older planet would be colder. How quickly they release depends on the interior structure and composition, cloud layers, convection, and so on, that can be rather complicated." Number 2. The strange, strong winds of Neptune. On the gas giants, there may be significant amounts of helium rain, changing the amount of heat released. For Uranus and Neptune, it's possible that they are at different stages, or more likely, the event that turned Uranus on its side may have jumbled its interior structure and/or released heat faster, Simon said. So, how about those winds? They are undoubtedly ferocious, and it's possible that this has something to do with the temperature. We've speculated for a long time that the coldness of Neptune and Uranus might lead to near-frictionless conditions and so allow for faster winds, said Heidi Hamel, a planetary scientist who has studied both planets extensively and was part of the Voyager 2 team that imaged Neptune. This implies that the winds are not slowed by the presence of mountains, hills, or other formations over the Neptunian terrain. Is there, however, a link between the storms and the source of interior heat? Probably, Hamel said, but there's also some delicate balance between the internal heat and the incoming sunlight. Number 1. What causes Neptune's winds to be so powerful? Winds are probably generated deeper than sunlight can penetrate, so a combination of internal heat and rotation likely produces them, Simon said, raising the question of why Uranus and Neptune's winds don't match, despite the fact that their rotation speeds are comparable. It tells us something is different between them. Partially internal heat or something else, Simon said. Uranus winds can reach 560 miles per hour, while Neptune's can reach 1,500 miles per hour. They're both extremely fast and peak at speeds faster than Jupiter, Tollefson added. According to NASA, Jupiter's Great Red Spot has a wind speed of 384 miles per hour. However, he agrees that internal heat alone cannot account for the speed, since Uranus does not create more heat. The internal structure of the planets, their masses, core sizes, and radial density profiles is crucial to understanding the winds we see. NASA's Juno and Cassini probes are now answering questions about how the winds arise and how deep they travel for Jupiter and Saturn. This is because they have incredibly excellent gravitational data, which allows them to make accurate simulations of the internal structure. We hope you enjoyed this video as much as we enjoyed creating it for you. If you did, don't forget to give this video a thumbs up. Comment down your feedback about the video so we can improve the viewing experience for you, and subscribe to our YouTube channel for more exciting content. Also, be sure to hit the bell icon so you get notifications whenever we post a new video for you guys.